Hello, everybody, and thank you for being here. My name is Gabriele Mazzini, and I'm a legal and policy officer at the European Commission. It's a true pleasure to be here with you today. And what I'd like to talk about is my journey through a European strategy for artificial intelligence. As you may know, the Commission has come up very recently, so the 21st of April, with the new regulatory framework for artificial intelligence. And so I'd like to use this opportunity of sharing 15-20 minutes with you to give you a first introduction to this topic, and to do so through a bit of my own personal experience, if I may say. So first, I'll explain a bit how I came to the Commission and sort of what triggered my interest in this topic, what I did actually in the run-up to this strategy. Then I'll discuss some of the key elements of this regulatory framework for artificial intelligence. And finally, I'll spend a few words on what's coming next. So to get started, I wanted to share here a couple of pictures from a project I worked with when I was in the United States. So before coming to the Commission. The project was called Millennium Villages Project and was an international project focused on facilitating economic development in certain areas of sub-Saharan Africa, notably across 10 countries. The project had a particular feature and focus, and was the use of new technologies to deliver certain outcomes, whether in health or agriculture or infrastructure or education. And so here I just selected a couple of examples. On the left-hand side, for instance, you see a mobile, notably a smartphone, with an application for mobile health. So mobile health plays a very important role when it comes to delivery of healthcare services in rural areas, notably through the use of community health workers. The second picture on the left, on the bottom, is more a solution for telemedicine. And on the right-hand side, you see what we used to call shared solar project. So essentially, these are off-grid systems for the generation of energy, notably through solar. And that is a shared system. So meaning that within that cabin, you have essentially a number of batteries and also a number of systems to allow users to pay for electricity as you go, essentially by using those scratch cards that you see in the picture there. People were able to pay just for a limited amount of energy, as much as they needed, without actually having to incur the cost of actually or really setting up. So these are just two, but by working there, I really developed a keen interest in understanding how we can fundamentally improve the Commission. I started, and you will see in particular, is at the center of it. In 2018, was by the Commission on Artificial Intelligence for Europe. The Commission set up on artificial intelligence, worked for and delivered two incomes. One was for trustworthy AI, was another document, another extensive document on policy and recommendations for trustworthy AI. Following the work of this, the Commission of 2020, so in actually a white paper on artificial intelligence, the basis for the was the basis for the extensive consultation, a number of regulatory AI. In fact, as you see, white paper was a European excellence and trust. So this of the European approach to facilitate an environment, an ecosystem of trust. But what is something that concerns us? Actually, yes. So AI has its place in really across all sectors of our society, our economic sectors, as well as societal sectors of societal importance. Here, for instance, you see just a number of examples. AI can be used in factories to automate processes. It can be used in the context of healthcare delivery, for instance, for surgical robots. It can be used, this is probably one of the areas that you're most familiar with, automated driving or driverless cars, as well as, for instance, drones and the delivery of packages. Finally, AI can be used also in direct interactions with humans, for instance, through robots. And in this case, you see pictures of children interacting with AI-enabled robots. However, when we discuss about AI, we don't always refer to those situations I've just talked about, where AI is essentially a component of a physical device or a physical product, and that AI essentially powers that physical product. AI can come also in many different forms, sort of as a standalone software. That's how we call it. For instance, your voice assistant in your phone is an AI, and that, of course, it comes through the medium of the phone, but it's pure software and advises you on your request or helps you find something on the internet and so on. Same for navigation, same for instance, systems. More. So, for instance, on the sign at the bottom, you see this video of President Obama, which was and so AI can in fact content that is not authentic and then be seen or perceived while actually it's not. It can also be used, for instance, in the medical sector, pneumonia, and actually it has been discovered to be as accurate as biologists. Finally, it can be used also in the justice sector. Courts systems to, for instance, assist that a certain person in a crime, or whether to be well in case they're released before trial. So these are all real world examples of use of AI. Let's do a step back. What is place? Is the definition of artificial intelligence in the proposal Intelligence Act has adopted on the. So in that document, as software, the set of human-defined objectives generate outputs, predictions, recommendations that have this particular environments that interact with. And all the examples I gave you before, whether there was about AI embedded into a product or AI that is sort of standalone, there is always an interaction between the output of the AI system and so the direct environment in which the AI system interacts with, whether that's so to say in the material world or in the real world, or whether it's more in the virtual world. Key features of AI, key components, I should rather say, of AI are three. So data, algorithms. Algorithm essentially is a set of instructions that a computer is given. And those algorithms, when it comes to AI, have become more and more sophisticated. And computing power. Computing power also, and thanks to the advances that there has been in the last few years, been essential for computers to be able to process large amount of data. So on one hand, we have more and more data. On the other hand, we need computing power to process those data. So these three components have made indeed AI be what AI is today, and so enable all those breakthroughs in all the sectors we've just briefly touched upon. So having said that, also say what is not AI, and in particular, certainly not magic. This is a concept. Humans are behind that are created, and the algorithms that are being, as well as the interfaces between those and the humans. So essentially, what I want to show you and underline indeed a very key concept is that AI per se is not magic, but at the same time of human ingenuity. As such, it can also imperfections. So as regards the collected data are supposed to run sort of real world. So data collected from the real world. those data represent how the result of a human decision. There may be some errors or some bias in the sound. As well, then those correct. Notably here you will find stays for machine learning, and machine learning is a bit of artificial intelligence. But are also created by humans, can also inject the way they design algorithms, certain our own imperfections in how we see and is. Then processing those algorithms lead to, so those outputs may in fact not perfect or be, lead to unintended. And those outputs on the data, and those data, the real world, so impact the real world is be further collected. So what is important to understand is that it has a great potential types in many, many sectors. Being the product of has to be properly according to certain standards and say to certain rules. Another example, AI is not. In fact, the term artificial intelligence, that AI is human intelligence. For instance, the picture on the left hand clearly a panda, classified by a machine, 7% confidence. That picture, and you to that picture, for instance, by certain pixels in the image, and you show the same image, which is actually the image hand side. In fact, for a human eye cannot see. There is not at all the left hand side, right hand side picture. There was an injection. They compete the picture on the right hand side, compact as you can see, as a given an image of confidence. But in fact, for a human, that the picture on the left is actually the same picture. Another example, I is not the same as human. The consequences can be here. Stop sign correctly classified by name. The second one, there are some sticks to the stop sign, so it's here and there. And so essentially, again, there is some noise. Unlike the noise we looked at, that noise to a human was perceptible to a machine, misclassified. In this case, is very clearly perceptible. So if you're drivers, which often happens, not that is not a stop sign. Intuitively, it's the same sign. A computer can be misguided. In that specific case, this classified as a speed limit. I think the case was miles, because the consequences can be turning very dire. What is important to AI is not like this, but AI used together with human intelligence. So here, in this is a recent on CNN. A false facial recognition, an innocent black man to jail. This is again where the machine may not, and therefore its use of about human oversight. A person with a crime and in possession of ID and a photo of the person suspected of a picture. The ID was false of the person. The police took that picture and ran a database of possible person who had to do with justice before. The algorithm, so this AI systems was a system, identified the match that the system, the picture of the with the database, pictures of people in the database, and then the police match, and then this person who was in the police with crimes in the past, 10 days in jail, an attorney to help, and it had to spend hours. Now, it turned out the match was false, and properly check that didn't do a good match. What does this tell us? Means can make mistakes, and the mistake was, and this is actually a common problem in certain systems, that those systems hint on data, or primarily of whites. They do not always work very well. Pictures of either or also person skin tone. Again, this is should sort of help us about how we use the system. Also, a problem that can be solved. That is what the European Commission, following I discussed before, and so that artificial intelligence or of the Commission on 2018 has the sum up with regulatory artificial intelligence, This proposal adopted the 21st of 2021. It's the first the word to establish a framework for artificial intelligence. This has been, the work I focused most year and a half. It has been seeing and rewarding work with my colleagues, and so we will see this will play out in the next. But before let me just quickly show slides on trying to achieve. So indeed, a new regulation on, and I want to spend time on is the so-called risk. The regulation, in fact, 4 areas. Why 4 areas? Because artificial intelligence is, there are situations where a certain regulatory response, some requirements systems must, in order to be put up, some other cases. So, and those requirements to the specific risk. From the bottom, we think that AI systems should not have specific requirements because they own no risk. Bandwidth that we think there are a number of AI which could generate, as regards in particular, whether a certain content or a certain product comes from a human, for instance, of customer service that uses any customers. Or think, for instance, in these situations, risk. And so it should be clearly identified. The really core of the regulation is, we think there are that may have an safety of persons, or for instance, a collect applications when you, or for instance, a medical device. The majority of this, in fact, on this type of. And finally, there are systems which unacceptable. They go against fundamental principles. These are very minority of AI systems. Systems we foresee on the orange color. An overview of is essential, trustworthy. So the kind of AI in place that AI systems that are of high risk should data set fully documented, so the developed proper documentation systems are well understood. So those systems need it by documentation. User of those systems understand. For instance, if CT scan assist by determine whether lesion is a melanoma or not, is to know how those systems. We mentioned this before. Developers of AI systems need a user of the type of has to be put in place. The system may not be human always the loop. Those systems should also lead to, and they also must secure, meaning those have to deal with inaccuracies that may happen within the system, be secure against attacks, like the about the stop sign. Be met by before they are put on the market, and they need to be checked in legal terminology ex ante, putting them on the market. Next, so as vision and legislative framework here in the function of the European Union, when the Commission makes it, has to be decided by the Parliament and the Council. Essentially, legislative procedures that the European Parliament agree among themselves on, and once they agree, proposal will become final. So we enter into force. Easy, but if you go a little bit into you will see how the procedure is complex. He foresees 3 readings, so 1 reading for Parliament, 1 second reading from Parliament, 3rd reading from Parliament. So the co-legislators, so I'll define the co-legislator, agree at any step, second reading or 3rd reading. They can. What's interesting here, each institution has features. So the Parliament work at the committee level first, and so on, and the Council has groups. Now, I will give you a bit of a sense of and how that happens a lot in practice. You see a box on trilogues or trilogues of trilogues that essentially there is between the 3 institutions. So to make the proposal, the Council, so the other 2 institutions to agree on the final text. Institutions often come discussion among them several stages of the procedure. There must be some formalized steps for the Council to express their. There are work also of negotiations which happens in the forms of trilogues. Go a little bit deeper, you see it happen at multiple stages. It implies essentially that gives a negotiating team that meets with the negotiating team, so they have some tentative agreement and then they report back and so on. And all this in circle, because that's where it will happen in the future, that the Commission has the fact that the Commission has made the proposal. The proposal is being discussed in Parliament at the same time. Doesn't mean that it completely forgets about what's happening. In fact, the Commission is always present at the meeting of the Parliament, meeting of the Council, and it will be available to steer the conversation between the two institutions. Which means, and for the colleagues of mine who act, a lot of work, who knows how long, but a year or two, in terms of really developing our thinking, preparing, making the negotiations. And so we think it's an exciting time. We are very much looking forward to this work. So basically, presentation. I know we covered a lot of extremely interesting, but also quite complex. Nevertheless, giving you the chance into what is AI. AI has triggered my interest. So hope that this also triggered your interest. I urge you to follow our few months and debate in any way to this really important debate that will shape the future in our economy in the next few years. And given that this is a framework on a global scale, legal framework across the globe. And good luck.